Hello everyone and welcome to Van Tech Corner. In this video, I would like to introduce a tiny x86 single-board computer from Icewell, the ZimaBoard. Unlike all the popular SPC which are using the ARM architecture, the ZimaBoard is having x86 architecture. Because of this, the ZimaBoard can run varieties of OSs and it can be used for different applications. You can install the OpenWRT and turn the device into a powerful router, or install pfSense to make it a secure firewall system. You can also install Windows and other Linux distributions on the tiny board. Not forget to mention that the ZimaBoard runs CastOS out of the box. It is an open source home cloud system based on the Docker ecosystem. You can install and manage all your Docker applications with the elegant web UI. Some of the popular applications we can name is Pi-hole, Qubit Torrents, Home Assistant, and even Unified Controller. All of them can run on CastOS or on the ZimaBoard. Now, let's have a check at the device specifications. The ZimaBoard comes in three models: ZimaBoard 216, ZimaBoard 432, and ZimaBoard 832. Each of the models has a different RAM and onboard eMMC storage. Besides that, they all have the same I/O ports and features. For the I/O, you will have 2 Gigabit Ethernet port, which is powered by the Realtek A1118 chip, 2 USB 3.0 ports, 1 mini display port version 1.2, which supports up to 4K 60Hz, 2 6Gbps SATA ports, and 1 PCIe 2.0 X4 slot. Speaking about the features, the board supports VTD and VTX virtualization. It also got the Intel AEX new instructions for fast and secure data encryption. The device supports H.264, H.265, MPEG-2 and VC1 video decoding, and supports up to 1080p video transcoding. So, what is the differences? With the ZimaBoard 216, you will have the Intel dual-core N3350 CPU with 2 GB of DDR4 RAM and 16 GB of eMMC storage. With the ZimaBoard 432, you will have the Intel quad-core N3450 CPU, 4 GB of RAM and 32 GB of eMMC. And finally, with the ZimaBoard 832, you will have the same CPU Intel quad-core N3450, but with 8 GB of RAM and 32 GB of eMMC. According to the ZimaBoard website, their boards have the TDP of 6 W and the recommended power supply is 12 V and 3 A. With the small form factors and passive cooling, the board can be used in different applications. As a networking guide, I want to see the device performance when it is working at a router, and I'm going to give it a try with OpenWRT. If the 2 onboard Gigabit Ethernet ports are not enough, you can expand it with a network adapter connected to the PCIe X4 slot. Now let's install the OpenWRT on the ZimaBoard. I don't want to delete the device OS which were installed on the eMMC storage. Therefore, I'm going to use a USB stick for this kind of installation. So let's go to downloads.openwrt.org and get the stable release of OpenWRT 21.02.2. Let's go to x86 and right here let's go to the 64-bit version. Alright, so I'm going to select generic ext4 combined, okay, and get this one. In the meantime, we can connect the USB to the computer and then using root first to write the image to the USB stick. The file had been successfully downloaded. So let's go back to root first, and then click select to select the OpenWRT firmware. Select our firmware and hit open. And now let's press start to begin. OK and OK. We can see that the USB stick is ready and we can remove it from the PC. Alright, so here is the ZimaBoard, and I have connected a USB keyboard to change the boot settings, and also a display port, a mini display port, so that I can see what is going on with the screen. Let's connect the USB stick to the board. And right here, as you can see, I have connected one Ethernet port to the ZimaBoard. This one is my WAN port. And right now I have yet to know which one is the LAN port or which one is the WAN port. So it is just a blink try. So this yellow cable is connected to my PC. Right, so let's connect it in. And now let's powering on the board. I'm not sure what kind of key we need to press, but I will try to press the delete key, and yes, we get right into the BIOS of the ZimaBoard. So let's have a check. Advanced Trusted Computing, chipset security, and boot, and let's see. Okay, right, so I want the very first boot to be the USB, and then the second boot will be the MMC, and the last boot will be the Debian. Okay, so let's go back and save the change. And yes, OpenWRT is booting on the ZimaBoard. So perfect, everything is working right so far, and yes, that's it. Not sure if it is connected, but let's press the enter key. Right, Ethernet 1 link it down, Ethernet 1 link it up, and the link become ready, and perfect. So we have the OpenWRT router up and running. So that will be enough for the console, and now let's go back to the computers and proceed. As you can see on our window, the network adapter is showing unidentified network, and I assume that we are connecting to the WAN port of the ZimaBoard. So let's go and switch the port. So this one currently is connected to my PC, and this one should be the WAN port instead of the LAN port. So let's go and swap it. Right, so this one should be the WAN port, and then this one should be the LAN port, just like this. All right, so LAN port and WAN port, and perfect. After we connected the computer to the right port, we have a new network, and let's press yes. That looks great. So let's open a new tab and go to 192.168.1.1, and let's log in. Alright, so I think we need to open a private window. So here is the OpenWRT running on the ZimaBoard, and we can see that the CPU is Intel N3450 at 1.1 GHz. Okay, so 2 GB of RAM, and on the network interfaces we have everything up and running. We have two network interfaces, Ethernet 1 and Ethernet 0, and the bridge LAN, the BR LAN is connected to Ethernet 0. So Ethernet 0 is on your right side and Ethernet 1 is on your left side. So let's go to system and then administration to set up a root password. And now we can see that there is no internet connection because my routers, my ZimaBoard is connected to an upstream router and it's received LAN IP address. So never mind, I'm going to change my router IP address to maybe to 192.168.3.1 and we will have a check. Alright, so let's go to 192.168.3.1 and here we are. Let's go to system and set a new hostname. Right, so now we should have a working internet connection. So first of all, let me have a quick check. Let me just minimize demos and open a new tab. Go to 192.168.3.1. Accept the root and my password. So this is OpenWRT stable release running on the ZimaBoard. So let's run OPKG update to update the dedication database. And meanwhile, let's open speed test. Alright, so OPKG install htstop and let's go. Let's run htstop and start a quick speed test. You can see we are running at around 350 Mbps with the firewall authority disabled, so we are on the stock configuration, and the CPU load is very small, so it's only around 17% on 2 cores. Okay, so let's open the browsers. Let's go to 192.168.1.157 and then the port 3000. So this is an open speed test server running on my one side. You can see we are running at 192.168.3.1 and this server is from the one side. So let's have a quick check on the speed. And you can see we are running at around 1 Gbps with just 60% utilization up to cores. So let me run a quick iPub test as well so that we can see what is going on. We can see that with hardware and software offloading disabled, we are running at 949 megabits per second with just 2 cores at 70%. So let's go and enable the software and the hardware offloading and let's see if we have any changes. So let's go to network and then firewall and enable software offloading and give another try. Alright, so let's start with the open speed test. We can see that software offloading doesn't make a real difference in the performance, as we can see the CPU utilization is more or less the same with previously. So let's run the iPub test again. And we can see the CPU utilization is more or less the same with previously, so there are not much differences. So let's try and turn on hardware offloading as well, and let's see if it's work. Let's go, start. Alright, so it looks like there are no much differences and Yep, the CPU utilization is more or less the same. So let's go with the iPub3 test for another time just to confirm that we have the correct result. And yes, the speed is the same because it is a limit for gigabit Ethernet, but the CPU utilization is still the same. So let's see if packet steering is enabled on this router. And alright, unfortunately it will not enable. So I'm going to enable this one and go back with the test. Alright, let's go and hit enter. So we can see that packet steering didn't make a real difference as well. And the CPU lot is still on core number 0 and core number 1. Okay. Alright, so we have the ZimaBoard up and running with OpenWRT. And right now I'm going to change my WAN connection to PPOE, and we are going to set up an internet connection. So let's just do that. So right now we are directly connected to the ISP modem and we have no internet connection because of course it is not running on GSCP client anymore but PPOE. So let's go to the device tabs right here and create a virtual interface. This one should be a VLAN interface and the base interface on the WAN interface. So VLAN ID 35 and this should be enough. So let's hit save and then save and apply. Let's go back to the network interfaces tab and delete this 1.6 interface. We don't need the 1.6 interface anymore because with the PPOE connection, it will automatically create a IPv6 tuner. Let's click edit the WAN interface. And then the protocol will be PPPoE and hit switch protocol. Change the device to Ethernet 1.35, which is our VLAN 35, and fill in the PPoE account which you get from your ISP. Alright, so after you have filled it in, let's go to the firewall settings and make sure it is assigned to the WAN firewall zone. Everything correct. Hit save and then save and apply. Let me disconnect from Wi-Fi so as we only have the Ethernet connection up and running. Alright, we can see that there is some traffic. We have some TX and yes, we received the IPv4 and IPv6 from the ISP and the internet connection is now up and running. So let's see what kind of speed does we have. Let's go. Not bad, we are running at 420 Mbps with the CPU utilization share across all cores. And actually I'm using a 200 internet plan, so it should be 200 upload and 200 download. But in this case, I have some speed boost when connected to the test server from my ISP. So let's go and change another server. And let's see. And yes, with 200 Mbps speed test, we can see that the lots share between 3 cores. And actually I'm not good in terms of like calculating, so let's run top and let's see the actual CPU utilization. So 86% CPU idle with 200 Mbps on VLAN 35. Alright, so we are running 200 Mbps with around 25% CPU utilization and we have 75% CPU idle, and for upload it is only 15% utilization. So to me, the results are very good because I don't expect too much throughput on the small and tiny single board computers, but I will focus on VPN performance and some SQM tests. But this will be for the next videos because this video should be very long already. So thanks for watching and see you in the next video. And just in case you have any suggestions or what kind of tests I should do on this tiny ZimaBoard, feel free leave it in the comment section. Thanks for watching and see you all in the next video. Have a great day and bye bye.